Welcome to Lesson 2. Before we get started, there's something I want to make sure you understand. Computer science, more than any other subject, builds on itself. That means that the things you learn today depend on the things you learned in the previous lesson. If you haven't mastered the material from the previous lesson, you should review it or go to the practice problem area and keep practicing problems until you are confident. You will not understand the new material until you do that. And that brings me to my 3 keys to success. Number 1, bring a notebook to class and take notes. Write down anything that is highlighted. When you see Alec writing, you should be writing. Number 2, don't give up on a problem. Some problems will take longer than others to solve. Don't give up or skip ahead. Work at it until you solve it. Remember, you are learning how to solve problems in general, and not just how to solve that particular problem. Once you figure out how to solve problems in general, they will get easier and faster to solve. And lastly, don't fall behind. If you're not getting a topic, re-watch the video or go to the practice problems. Don't move on until you understand a topic. Whatever time you spend catching up will be less than the time you'll eventually have to spend if you move on without mastering a topic. With that said, let's move on to variables. By the end of this lesson, you should be able to describe what a variable is, list variable types and describe the data that they can hold, state the syntax for a variable declaration, explain how to put data into variables and how to get data out of variables. So what is a variable? A variable is a named location in memory that stores data. I realize that's a little vague and complex, so here's a simpler definition. A variable is a box. It's a box that has a label and a size. Let's take a little trip so you can see what I mean. In order to help you visualize what a variable is, we've taken a trip to Cleveland Menu Printing. Cleveland Menu Printing is a company in Cleveland that, well, prints menus. You've probably never heard of Cleveland Menu Printing, but they print menus for thousands of restaurants, hotels, and even cruise ships all over the country. Shipping the menus to the restaurants and hotels is a big part of their business. I'm here in the shipping department with Mark. Mark is responsible for shipping hundreds of thousands of menus all over the country every year. Mark's not a programmer, but what he does is similar to what you'll need to do when you write software. Listen to him explain what he does when he receives an order that needs to be shipped, and see if you can think about how that's similar to what you're going to need to do when you're writing code.
So the first thing I do when I get a cart that needs to be shipped is break the product down in size. And here we have inserts, covers, and a bag of tassels. And then I find a box that fits them appropriately. This will be for the inserts, this will be for the covers, and we're going to use an envelope for the tassels. And the first thing that's very important is to label them first. So we have labels here. So the first one's the tassels, then the inserts, and then the covers.
Now, as you can see, it doesn't make any sense to take the tassels and to put them in this box. It's way too big. It would waste a ton of space, you'd have to put a ton of packing material in, and there's really no point to it. Very inefficient. Likewise, these inserts aren't going to fit in this envelope. You can try all you want, but that just isn't going to happen. So how is what Mark is doing similar to what we're doing? Variables have a size, a name, and they store data of a particular type. In Cleveland Menu's case, they had products that were of a particular type. They had menu covers, menu inserts, and menu tassels. Each product needed a box that it could fit into. In the case of programming, we have data of a particular type. For example, we have whole numbers like 1, 2, 20, 2 billion. We have numbers with decimals like 1.1, 2.1, 20.1, and 2 billion, Point 1. We have text like my name, Alex's name, the Declaration of Independence. We have single characters like A, B, C, and we have single bit, something that represents true or false, yes or no, on or off, 0 or 1. In the case of numbers, we also have a large size and a small size. The type of variable tells what it can store and how big it lists. Look at this list. For whole numbers, the variable type is int if it's a small whole number, and small is defined as values between -2 billion and +2 billion. I realize that's not what you might consider small, but look at the next size up. Long is a variable type that holds whole numbers that go from 9 quadrigajillion to -9 quadrigajillion. And that's not the actual name. I don't know what the name of that number is, and you won't be expected to know it, just to know that it's very, very big. In the case of numbers with a decimal point, you have float, which is smaller decimal numbers, as in 3 times 10 to the 38th, or double, which stands for double precision floating point decimal, and it is the large version of a decimal, which goes from 1.7 times 10 to the 308th to -1.7 times 10 to the 308th. Incredibly large. Char, C-H-A-R, is a variable type that holds single characters like A, B, C. String, with a capital S, contains a collection of characters. It can go up to about 2 billion characters. Boolean is a single bit. It's a 0 or a 1. It can be used to represent true or false, yes or no, cool or not cool. Just kidding. Now, you might be thinking, why would I want to store whole numbers, decimal numbers, Boolean, and text? Well, let's consider a few examples. Think about your teacher's gradebook. Gradebooks are all software applications these days. When your teacher records a grade for an assignment, the system needs to store that data somewhere. If it didn't, the teacher would have to re-enter the grade every time he or she opened the gradebook. That would be insane. What type of variable would you use to store the grade? That's actually a tough question, because you have to determine if you're recording points, which would be a whole number, percent, which would be a decimal, or the letter grade, which would be a string. We'll get to that later when we build Alec his GPA calculator. If the gradebook analogy isn't working for you, think about playing video games, like Pokemon Go. As you're running around the city picking up little Pokémen, the system needs to keep track of how many of the little critters you've picked up. That's the type of thing that would be stored in a variable. Let's practice picking the right variable type to store data. Make sure you have notes on the variable type and the data that they can hold, and then click Next and practice assigning types to data.